Hi everybody, this is Lars Wemmje, and welcome to another LoveFX tutorial. In this tutorial I'm going to talk about Nuke's UnrealReader and the important things I learned during the creation of this shot. If you want to watch an in-depth version of this tutorial, in which I mainly talk about the compositing of the shot, and if you want to download a reduced, watermarked, and one frame long version of the script, you can become a gold supporter of my Patreon page and get access to it. I'll leave the link to it in the description of this video. Although I have waited a long time to finally start learning Unreal Engine, I have to say I can absolutely see myself continuing to use this tool in the future. Please keep in mind that I'm just sharing what I've learned in the last few weeks and what I believe to be valuable information for fellow compositing or digital artists. When it comes to hardware requirements for the usage of Unreal Engine in combination with Nuke's UnrealReader, you have to make sure that your system can handle what you throw at it when you are creating a big environment with a lot of high-res Megascan assets. Apart from having a decent multi-core CPU and at least 64 to 256 gigs of RAM for a nice user experience in Nuke, I would recommend you to use an NVIDIA RTX GPU with at least 8 gigs of VRAM to make sure you can feed Nuke, Unreal Engine, and your PC with a few gigs of VRAM. I'm using an RTX A4000 that has 16 gigs of VRAM, which I'm really happy with at the moment. Before we jump into Unreal Engine and then into Nuke to talk about the UnrealReader, please make sure to check out the most recent version of the Nuke server plugin for Unreal Engine and Foundry's tutorial, in which they show you how you can connect Nuke to Unreal Engine with the UnrealReader. I'll leave the link to the Nuke server plugin for Unreal Engine and Foundry's tutorial in the description of this video. Okay, now let's check out the level I've created in Unreal Engine to render my shot. Once you have created a level that you would like to render, you need to create a sequencer, which is where you can work on the animation in your scene. That includes cameras, metahumans, objects, and so on. With the workflow I'm about to show you, you have a few options when it comes to camera animation. You can create an animated camera in Unreal Engine. You can easily import an FBX camera into Unreal Engine that you might have created in Maya or Houdini and so on. Or you can create a camera in Nuke and connect it to Nuke's UnrealReader. For this project, I decided to animate a camera in Maya, bake the animation in Maya, and import the camera as an FBX file into Unreal Engine to render my shot with the UnrealReader. Here is a very important point that you need to be aware of when working with Unreal Engine, which is your GPU's VRAM usage for the texture pool size. If you paste the following command line into this field where it says Enter Console Command and hit Enter, you can take a look at the Output Log tab and see how big your current texture pool size is. That means the amount of your GPU's VRAM megabytes that Unreal Engine is allowed to use at the moment. If you have a few gigs of VRAM to spare, you can enter the previous command line into this field again, or just press the up arrow, then you can hit the spacebar, enter the amount of VRAM megabytes you want Unreal Engine to use for your texture pool size, and hit enter. This will also make the workflow between Unreal Engine and Nuke run much smoother, and it will give you less crashes. But you need to reserve a few gigs of your GPU's VRAM for your operating system and for Nuke. Once your sequencer is already using the camera you want to use, and assuming that you have already installed the Nuke server plugin for Unreal Engine, you can open it and click on Start Server. Alright, let's jump into Nuke to take a look at the UnrealReader. This is the demo shot that I created for this tutorial. If you want to know more about how I transformed this CG render into this shot, you can become a gold supporter of my Patreon page and get access to an in-depth tutorial of this shot and download a 1 frame long, watermarked and reduced version of this Nuke script. Now let's create a new UnrealReader node. Once you have connected your viewer to it, you can click on this button where it says Connect to Server, and then you have to select your map and your sequence in these drop-down menus. As soon as your scene is loaded, you can go to another frame in your timeline and watch how the image will update. And just like I mentioned earlier, you can also connect a camera in Nuke to the UnrealReader and work on your camera animation in Nuke if you want to. At the moment, the UnrealReader is showing me a 4K image that is being generated by the Unreal Engine in the background, and it's showing me an updated frame within a few seconds whenever I'm jumping to another frame. I think that is pretty awesome and wild because it enables you to create shots in Nuke, render them super fast with the help of the UnrealReader, and comp your shots in Nuke. For the remaining time of this tutorial, I will stop the Nuke server in Unreal Engine and talk about the most important things that I've learned about this workflow during the creation of this project. I think the most important thing I learned was the usage of this command line, which I talked about earlier. And again, the number stands for the amount of VRAM megabytes you're willing to give Unreal Engine for better performance. I also learned how to use the render quality settings in the UnrealReader node, which you can find in the Advanced tab under Anti-Aliasing in these two fields. You can think of the spatial sample count as a value that stands for the anti-aliasing and overall image quality, and you can think of the temporal sample count as the amount of steps that define the smoothness of your motion blur. If you want the UnrealReader to render your image sequence without motion blur, you should set your temporal sample count to 1 and activate the Disable Motion Blur checkbox. Here are two overviews that can help you to understand the render settings a bit better. By comparing the quality of these two images relative to the settings I used to render them. In the first overview, you can get a better idea of the image quality settings, and in the second overview, you can compare the render settings relative to the image quality and the quality of the motion blur in these images. Keep in mind that once you have given your temporal sample settings in the UnrealReader a value above 1, you can start to see some motion blur in your render, even if you have disabled your motion blur in the Advanced tab. Now let's talk about render passes, which you can take a look at in the Render tab. It's very important to understand that at the moment, it is not possible to rebuild your beauty render from the passes that Unreal Engine is able to give us. And unfortunately, it also doesn't support light select passes. That is not due to the UnrealReader, but due to Unreal Engine. Who knows, maybe that's a feature that will be added in the future. Another interesting point is the path traced rendering in Unreal Engine, which the UnrealReader gives you access to by enabling the respective render paths in the Render tab. So far, what I've learned is that the path traced rendering can look better than the regular real-time rendering, judging by what I've seen other artists create. But I could not get the path traced render in Unreal Engine to look better than the real-time rendering mode yet. Of course, that is just due to the fact that I'm a beginner in Unreal Engine. Here are 3 versions of the same path traced frame rendered with varying quality settings. If we compare a path traced image to the Nanite and Lumen real-time version, you can see that the latter version has a lot more details. This UHD image sequence took 1 hour and 60 minutes to render with the UnrealReader. I rendered it with 5 spatial and 10 temporal samples, and I consider the render quality settings that I used for this shot to be pretty high. I'm really excited by the rendering speed of Unreal Engine. Once you're ready with the settings of your UnrealReader node, and you are sure that it's connected to Unreal Engine, you can render an image sequence of your shot by going to the bottom of your UnrealReader tab where it says Write, typing the file path of your EXR sequence, and clicking on this button that says Write to Disk. Before I go, I want to thank Foundry, Tony Lyons, Victor Perez, Benjamin Jenrich, and all of my Patreon supporters for their help and support. Thank you very much. I really appreciate your help. Alright, that was it for this LoveFX tutorial. I really hope you liked it. And again, if you want to watch an in-depth version of this tutorial, in which I mainly talk about the compositing of the shot, and if you want to download a reduced, watermarked, and 1 frame long version of the script, you can become a gold supporter of my Patreon page and get access to it. I'll leave the link to it in the description of this video. If you want to watch some more of these videos, don't forget to subscribe. And if you have any questions about my work, feel free to post them in the comments. Again, this is Lars Wemmje. Thanks for watching, and goodbye everybody.